Bookwork, I've spoken about bookwork already. Learn your bookwork. Make lists of the things that you need to know and look at, define equilibrium. There are lots of things where they ask you to define equilibrium, define this, define that. What is the law of conservation of linear momentum? Write down a formula for the law of linear momentum. That formula that you can write down, you can actually turn that into words as well, which is a statement of the law. Learn that bookwork. It's a good discipline and it will help you. Okay, here we've said forces, projectile motion, momentum, work energy theorem, power questions, Doppler, electrostatics, circuit problems, electromagnetism and AC, photoelectric effect. Those are the 10 questions. Now, very often you will find something like electrostatic might go from one question into the next question. So you've got a little more than a question on electrostatics. Work, energy and power. Sometimes we will find forces, for instance, a force question tied up with a work question. And so there are mixing of these categories. They're not absolutely cast in stone. And sometimes we will do a little bit more on one than the other. And that changes from exam to exam. But by and large, the breakdown is pretty even. But when you go through old papers, just look at how the questions have been broken down and what topics are where. Now on to paper 2, the chemistry. The data sheets, they're 4 pages. They're at the end of the paper. The periodic table of elements, and I hope you're going to learn to understand and read and interpret and use the periodic table. So much of chemistry, if you know how to use the table properly, is there. Electron configurations, they're all there if you know how to extract that information. Physical constants, not as many for chemistry, and formulae, also not as many. Know what they are, know where they are, know when to use them, and know where to find them without any ado, because that's part of the preparing yourself for the exam. Know your way around that physical piece of paper that gets put down in front of you. And then, of course, standard reduction potentials. Now, there are 2 of these tables, 4A and 4B. Decide which one you want to use. I know my preference is for 4B because a spontaneous reaction, we can always write that C. It starts up at the top right, it goes back to the top left, it goes down, and then it goes across again. And that's your reaction that will be spontaneous only on that table, not for 4A. But use whatever your preference is. It doesn't matter as long as you use them consistently. Paper 2, again, this hasn't always been like that. There used to be short questions and various other types of questions. It seems now that we have settled into 10 multiple choice items for the chemistry as well, 2 marks a pop. Questions 2 to question 10, long questions, show the formula, substitutions in calculations. I made the point earlier. Please be careful of that. Rounding off to 2 decimal places. The paper actually says 2 decimal places minimum, which means that if you get an answer to 3 decimal places and they're all significant numbers, 1, 2, 3, then you can put all 3 of them down. But in most cases, these numbers are all just going to be generated by the calculator, so correct down to number to the 2nd decimal place. Same thing about motivations and discussions as in paper 1. Organic chemistry, all right, you've got bookwork again. But in the long questions, organic chemistry can extend into a couple of questions. And what is more, in other chemistry questions, you might find a little bit of organic molecules being dealt with. Generally, it's not organic chemistry as such, but they're just using organic chemicals for examples. But the organic chemistry itself is a big section, a very important section, and it goes into almost 2 questions, sometimes maybe even a little more. Reaction rates and reactions themselves, these could use organic chemicals as the examples. But what is being tested is reaction rates. Reaction, the energetics, potential energy curves, and the way the bonding curves and all this sort of thing. That kind, distributions, Maxwell-Boltzmann distributions, all of those curves, you need to understand how to work them. When you've got an exothermic reaction and so on. You need to know those curves and what they mean. Lots of questions involve them. Equilibrium and equilibrium problems, usually get those. Acids and bases, sometimes they're a whole question, sometimes they're not. Electrochemistry usually goes into more than one question because there's a bit of electrochemistry in the chemical systems and industrial applications, electrolytic refining of metals and so on. And then it's become quite common to get a fertilizer question. You get 2-3-2 fertilizer to put on the lawn. What does all this mean? And so on, and work things out. Those kinds of problems. And also NPK, the primary nutrients and what they do and so on. All of this tends to come up quite regularly. Okay, tip on time management for the last time. 150 marks, 3 hours, 180 minutes, 1 mark per minute. Use your accumulated fat, which starts off at 30 minutes. Use it wisely. Use it to read your questions carefully. Please, please, please do that. And that is it. It's a wrap. It's all over to you, and the very best of luck to you. I hope you do well.